So now we've learned the basics of how to set up a difference of perfect squares on the bottom so that we can get rid of any radicals that are on the denominator. This one's going to take it up a notch because now they each have a radical, and it's just going to show you that actually this isn't any more complicated than the last one, because we're just going to do the same thing. We're going to set up the difference of perfect squares on the bottom, and because I'm going to be multiplying this number by itself and this number by itself in the first and last steps, they're going to cancel out as well. So let's get started. I use the same numbers. I just switch the sign. So now I have multiplying by something that equals 1 because it's something over itself, and I have the numbers set up the same as on the bottom, but the sign has been reversed. So that should give me a difference of perfect squares on the bottom, which should get rid of all of the stuff I don't want, the radicals, and I don't care what happens to the top, I'm just going to work that out. Okay, so let's just save ourselves a little room this time and set up the brackets right off the start. Now I can start with the top. Let's just put a line there so we can guide what we're doing. And I'm going to go first. 5 root 3 times 2 root 6. 5 times 2 is 10. Root 3 times root 6 is 18. We'll leave it for now. You might start noticing as we work with radicals more often when we're going to have something that's going to need to be simplified. 18 has 9 as a factor, so we're going to have to go back to that. For now, though, we'll just keep going. Outside, I have 5 times negative 4 gives me negative 20. I have root 3 times root 3 gives me 3, so I'm just going to put that in brackets. Actually, just going to switch that a little. There we go. Inside, I've got root 2 times 2, so that's like there's a 1 out here. So that's both positive 2 root 12. Oh, yeah, 12. Remember that that's going to have to change. And then we've got the final one. So root 2 times negative 4, so the negative 4 will remain, and that becomes root 6. We got the top part under control, and we're not going to bother foiling the bottom part because we know it's a difference of perfect squares. So all we're going to do is square this one, and well, we'll do that first. 2 root 6 squared is 4 times 6. Root 3, remember that this is a negative. 4 times 4 is 16. And root 3 times root 3 is 3. So now we just have to simplify all of our good work. Starting with 10 root 18, I know that 18 is 9 times 2, and I know that 9 can be square rooted into 3. So the 3 is going to have to be multiplied by the 10, which is going to give me 30 on the outside, but only root 2 left over that I didn't solve. I'll just extend that line a little bit. In here we've got a negative. 20 times 3 is 60. That's pretty straightforward, I think. We look at 12, and 12 can become 4 times 3. So the 2 comes out, and that's going to be combined with that 2, so we will multiply that to a positive 4, and the root 3 stays behind. And minus 4 root 6, there's not really anything we can do, so we just bring it along. Now on the bottom, we've got 4 times 6 is 24, and we've got 16 times 3 is 48. 24 minus 48 should give us negative 24. So now that we've got that, we want to just take one last look and ask ourselves if there's a factor that comes out of everything. Remember that it has to come out of every single coefficient, the big numbers outside the radical. So I've got 30, 60, 4, 4, and 24. You want to be tempted maybe to use 4, but that's not going to work because it doesn't come out of 30. So we're just going to have to settle with 2. We can reduce all of these numbers by 2, so our final answer becomes 15 root 2 minus 30 plus 2 root 3 minus 2 root 6 all over negative 12. We can look one last time and ask ourselves if there's anything further we can simplify, but it looks like we're good. This 15 will stop us from reducing it anything further.